This question says, a solution is prepared that is initially 0.22 molar benzoic acid and 0.16 molar sodium benzoate. Complete the following reaction table below so you can calculate the pH of the solution. So first, let's look at the reaction. We have HC6H5CO2 aqueous plus H2O liquid yields, this is the acid, this is the base, H3O plus aqueous, so water gains a proton, plus C6H5CO2 minus aqueous. So this is our reaction here. And now we can set up an ice table, which I should have done on the previous example. So here we can have the initial concentration. Well, the initial concentration of benzoic acid is 0.22. Water doesn't matter because it's not in the equilibrium expression. The initial concentration of H3O plus is 0. And here's where it gets interesting. What is the initial concentration of C6H5CO2 minus? In previous examples with strong acids, this was 0. But here, we added 0.16 molar sodium benzoate. When you dissolve sodium benzoate in water, you get Na plus and C6H5CO2 minus. Said another way, this has a common ion effect. So this 0.16 molar is the concentration of C6H5CO2 because when you take NaC6H5CO2, let's call it a solid, and you dissolve it in water, you get Na plus aqueous plus C6H5CO2 minus aqueous. So for every 1 mole of this, you get 1 mole of this in solution. Said another way, this is 0.16 molar. And I'm leaving off the symbols. So when you initially dissolve this, this is going to act as an acid and react with water and drive the reaction in this direction. So we're going to lose X amount of this. And because all the stoichiometry is 1 to 1, we're going to gain X of this and gain X of this. At equilibrium, the concentration of the acid is 0.22 minus X. The concentration of H3O plus is X. And the concentration of C6H5CO2 minus is 0.16 plus X. Note that this is in a slightly different order. The acetate ion comes first and the H3O plus comes last, so you just need to plug it in the appropriate order.